Okay, so now let's maybe try it first on this first on the small picture, and then we can try this again on the bigger picture, right? Okay, so let's close everything for now, and we want to implement multigrid. So the input is actually the same as what we had in the Poisson's equation, or in Jacobi iteration. The input is x, x and b. So basically the original, well, let me just call it the original x to be x0, and my updated x to be x. So this is my multigrid iterations. So what's the first step in multigrid, one multigrid cycle? Pre-smoothing, right? I want to apply a few Jacobi iterations. So for I goes from 1 to, let's say, 10, okay? I want to apply the Jacobi iteration. So x, just to say x0 equal to Jacobi x0 and b. So here I applied 10 Jacobi iterations. Not much. As you've seen the result of hundreds and thousands of Jacobi iterations, 10 Jacobi iterations doesn't really do much, right? Except for it actually smoothes out the solution error just a little bit. So after this, what we want to do is to compute the residual. What is the residual? It's simply the left-hand side minus the right-hand side. It's the we already know how to apply the matrix. So Laplacian of x0 minus b, right? So that's my residual. Okay, and then we want to interpolate. So since I mean, in general multigrid, you probably have to write a pretty complicated function to interpolate. But in this particular case, we actually have chosen a picture that is actually, well, it's 1 plus 2 to the whatever power, right? So interpolation in this case is actually very easy. We just choose every alternating grid point. So R cos is equal to R 1 to 2 to end, 1 to 2 to end. All right, so that's my interpolation. Find to cos. All right. Okay. Next, what do I do? Well, I solve the error equation on the Coarser grid. So let's first do something that is easy for now. So the Coarser grid solution would be also 10 Jacobi iterations, except for I know that the solution error on the boundary should be 0, right? So I would be just making RC equal to multiply 0. So that's my initial guess for the error, and my E is going to be Jacobi E with RC. Right? Does that make sense? So that's my very crude method of solving the error equation. I actually don't really need to solve the error equation. I only need to make some progress, right? So basically, afterwards, I also need to interpolate the error back onto the fine grid. So how do I do that? Well, again, usually you have to write maybe a long function, but in the case where my grid is exactly a power of to a certain power, it's actually relatively easy to do. So E at, let me call this EC, coarse grid error, and my fine grid error is actually, let's start it as R times 0. So basically, I want just a bunch of zeros the same size as R, right? Fine grid. So first of all, I want to say E from 1 to 2 to end, 1 to 2 to end is actually equal to EC. So I basically put the solution error at the alternating in the coarse grid at the alternating grid points. And then let me just do a linear interpolation. in between these grid points. So linear interpolation in x would be 2 to 2 end would be equal to an average of 1 to 2 to n minus 2 plus this with 3 to 2 to end, right? So basically I'm just averaging on the left and on the right. So all of this has already, okay, so basically the first one fills the odd grid points, right? This averages the if you look at the right hand side, they are all even grid points, this which is already being filled. It averages out the even grid points and put it on the odd grid points. Oh, sorry, it averages out the odd grid points and put it on the even grid points. And now this has been done for the I direction. I also need to do it for the j direction. So from 2 to 2 to end would be equal to e 1 to 2 to end minus 2 plus e 3 to end. So this is my very simple interpolation. Any questions on that? Just the average in the neighboring grid points that is already filled.
It won't fill all the points.
I think it does fill all the points, right? So here, this one fills the grid points that are even or that are odd in both x and y directions. Okay. The second line fills the grid points that are even in the x direction but odd in the second direction. Now these two lines, I have filled everything that is odd on the second direction. Now the third line fills everything that is also even on the second direction. All right. Yes? I am interpolating on both directions. Why am I not? So this is this line line 13 is interpolation in the x direction. 14 is interpolation in the y direction. Yes.
Are we losing some information after interpolating it from a Poisson grid?
Yeah, we are losing information when we interpolate from coarse grid to fine grid. But the information we lose is hopefully very, very small because the residual should be smooth after the pre-smoothing iterations. So actually one of the failure modes of multigrid is not having enough pre-smoothing iterations, so that you actually lose major information when you go to the coarse grid. I mean, we can try later on, for example, if I just do one jacobi iterations, it might fail. Okay. Yes? Mm-hmm. Let's see. So if you do, okay, so what we are saying is that we already have the values on the solid intersections. We want to also interpolate to here, right? So basically we already have the values here filled, right? So first of all, we say this is just an average of these two grid points, right? This is what's done in line 13. Line 13 is basically filling all of these. Are you questioning about this line or the next line?
No, yeah, like this direction.
Yeah, here I'm just interpolating in the x direction because I know these are the nearest grid points, right? Your question is why don't I take into consideration of these points? Yeah, I would guess you can make a more sophisticated interpolation scheme that uses these, but here I'm just looking for simplicity, right? So it's more kind of maybe you can try that, and maybe you get even faster convergence than what I get here. Okay, and the next line basically fills everything in between these alternating horizontal lines. Okay, so this is my interpolation. Okay, so here I think a very common mistake in multigrid is actually interpolating the wrong thing. So when you go from affine to cos, we are interpolating the residual, right? Not the solution, interpolating the residual. And when we go from cos to fine, we're interpolating the solution error, which is the solution of the same equation with the solution with the residual as the right hand side. Okay, and then the next thing is x would be equal to x0 minus e. That's it. Okay, so that's my implementation of multigrid.